Hello again, and we are going to be working with some rational expressions today. These are expressions which mean they are only to be simplified. Now, I covered a little bit of this with just basic algebraic functions and basic exponents, and I said in that video that we would take it up again after we learned how to factor. And since we have factored and started to learn how to factor and all that good stuff, we're going to work a few problems and see what we come up with. Now remember, these are expressions. So with that, we will work a few of them. Oops, excuse me. And we'll move on to rational equations after that. So the first thing you do when you're talking about complex rational expressions, the first thing you're going to do is you're going to factor. Factor everything. That's one of the rules. Factor everything. The reason you factor everything is because you need to see what will cancel. Because remember, we're trimming the fat off of the steak. We're trying to trim off anything that is repetitive, anything that, cancels out. And that's why we want to factor everything. So the first thing we're going to do is 3 over 6 times m over m. And as you can see, the m over m is 1. So we're going to factor, we're going to cancel that out. And then this is equal to 1/2. So we just simplified that expression down to 1/2. And those were the problems that we went over in the pre-algebra and the algebra 1, like number 2. We did one like number 2, and we'll do that one, and then we'll move on to the factoring. So this one, we can factor out 12, 3 times 4 times A times B times B over 3 times 5 times A times A. And if you will notice, take your red pen, our red pen is for canceling, that 3 cancels, that A cancels, and then you're left with 4B squared over 5A. Now, in those two problems, we factored out everything. We couldn't factor out, technically we could factor this to be 2 times 3, and then the 3's cancel, and there you go. But now we have algebraic expressions, and either they're already factored, and you just cancel those 2 out, you get C minus 1, or you have to factor. In this case, we got R times R plus 3 over R times R minus 3. And of course, you see that one of the R's cancel. And then you're left with, I'm just going to write over here, R times R plus 3 over R minus 3. And that's the answer to that one. Okay, now we're getting into these are the ones that we need to get into, because the first thing you need to do is factor everything. So these are algebraic. So we're going to try to factor out a common term as well as factor out whatever we can. We know a 10 is factored out here. So 2 times 5, and that leaves V plus 8, or 4, sorry. And then what's in common with 8 and 32? 4, which is 2 times 2, and that will leave 2V, or I'm sorry, 8. I'm sorry, 2 times 4. I'm sorry. That's a 4. I'm factoring out an 8, but I'm doing it so you'll see what happens. 2 times 4, I just factored out an 8, and that leaves V plus 4. And we take our red pen out, and we cancel out the 2's, and cancel out the 4's, and you're left with 5 fourths. So if you noticed, if you learned how to do all the factoring, this section just reinforces the factoring and is easy because you know the factoring. This one, we've got x minus 1 on top. We've got shortcut number 3 on the bottom, x plus 1 times x minus 1. And x minus 1's cancel. And you're left with x plus 1. 1 over x plus 1. Okay, I'm going to pull this worksheet up and we're going to work on 7, 8, and 9, and probably as well as the next ones. And like I said, if you remember how to factor, I'm trying to see, there. Okay, I'm going to erase this, so if you need, I've already messed it up, so there. Okay, so I'm going to take a break and I want you to stop the video and work on those 6 problems. And you're back, and let's see what happens.
At 6 o'clock, and we say, no, the money's there, and then.
So, the first one I'm going to, it's not a perfect square, so it's not a shortcut. So I'm going to use reverse FOIL, and that's going to give me D, 8 is 2 times 4. And we need a positive, so that means the 4 is positive, and this is net like, so, and then D, and 4 times 5, and this needs to be a -5, and this needs to be unlike, so that's a positive 4. We take our handy dandy red marker, and the D plus 4's cancel, and you're left with D plus 2 over D minus 5. Next, we've got shortcut number 2 here, or 3, H plus 3, H minus 3, over, parentheses, H, we know this is shortcut number 1, 3 and 3. I did it the long way, I didn't do the shortcut because I wanted you to see that the H plus 3's cancel, and you're left with H minus 3. I'm sorry, that's not supposed to be red. H minus 3 over H plus 3. Right here we've got shortcut, and we don't have a shortcut because 8 is not a perfect square. So F, and we need 2 and 4. This means a positive 4, this means unlike, and put that over 2, and that's going to give us F plus 2 and F minus 2, because this will give us 2 times F squared minus 4, and that's shortcut number 3, 2 times F plus 2 times F minus 2. Now, let me go ahead and tell you right now, if you're having trouble with the problems that we've done right now, if you're going, I have no idea what he's doing, then you need to go back to the video in this algebra review, and I think it's called Reverse FOIL and Shortcuts 1 through 3, because we've already covered this. So you need to go back there and you need to practice some more. And the F minus 2's cancel, and you're left with F plus 4 over 2 times F plus 2. Okay? Now that number 10, well, I don't think you can do anything with number 10 because that's not a shortcut. M squared plus 8 is not a shortcut. And that M squared would have to be an M cubed for you to use shortcut number 4 and 5. So I don't think you can do that one. We'll have to look at the answers. Let's look at the answers right quick. Let me move this over. Let's see if number 10 is prime. Okay, I don't have the answers on here, I guess. Nope, they don't have the answers. Okay, well, number 10 is prime. So I'm going to move on because you can't do, this would have to be M third plus 8 for you to do shortcut number 4, which is the difference of 2 cubes. And this is not M squared, this is not M cubed, and you can't take the square root of 8, so this one cannot be done. I don't know why they don't have the answers on this worksheet, but we're going to keep on going. Besides, I don't put those on the test anyway. J, and I'm going to use 1 times 6, and that's going to be a positive 6 and a positive 1. Excuse me. Now, that second denominator, I can pull out a 2j. That's in common. And that's going to leave me 6j squared minus 7j minus 10. And I'm going to try to factor that but I wish I could copy that. I bet I can't. Let me see if I can copy that. Yeah, I can. Good. I'm going to copy that. We're going to go to a whiteboard, and we're going to finish this problem on the whiteboard. All right, so I'm going to do the bottom, 2j, parentheses, parentheses. And I know that 6j could be 2j and 3j and 1j and 6j. And then that 10 could be 2 and 5 and 1 and 10. I need a 7 in the middle. I'm trying to see, I'm just going to go ahead and start with 1 and 6. I'm going to put a 1j here and a 6j here. And then I'm going to put a 1 and a 10. 10, 60, that won't work. 10 times 6 is 60. I need a 7. That's not going to work. So I flip it. 1 and 6. 10 will go here and a 6. That'll give me a 4 and a 16. That's not going to work. So let's try a 5 and a 2. 5, that'll give me a 5 times 6 is 30. That won't work. 2 times 6 is 12. That's it. 2, 6. 1 times 5 is 5j. 5 and 12 will give me a 7. I need a negative 7. So that means the 12 is going to be negative. This means unlike, so that's going to be positive. So that's my bottom. Now, if you do not understand what I just did with that 6j squared, then you need to go back to the reverse FOIL and back to a worksheet and do some more because you haven't got the reverse FOIL down. And this is going to be j plus 1 and j plus 6, and I don't see anything that will cancel. I thought I would be able to get something to cancel, but I don't see anything to cancel. I'm going to try, wait a minute. I'm surprised. No, I don't see anything that's going to cancel. So, unless I'm mistaken, I don't think that one can be, I don't think you can do anything with that one either. Unless I'm missing something there. That one looks like it's not factorable. One and 6, factor out of 12, a 2. I'm checking to see if I wrote that down right. Well, let's check with the FOIL method and see if we get what we get. So first is 6j squared. Outside is 5j. Inside is 12j. Last is negative 10. So 6j squared minus 7j, minus 10. There, you can't, I don't see anything that would cancel. So I don't think you can do anything with that one either. Okay? It's not a good one. Let's see if we can do something with this one. So, 2, can't factor anything out there. We can factor out a 2 right here, but that's not going to help us because we get a 2y squared minus 3. I don't think we can do anything with that. That'd be 2y squared minus 3y. No, we factor out a 2y. I'm sorry. Factor out a 2y. Factor out a 2y on the bottom, we get y minus 6, minus 3. 2y minus 3. There we go. 2y minus 3. And then on the top, 2 sets of parentheses. And I'm going to do 1y and 2y. And then maybe a 3 times 6. 12. Yeah, give us a positive 12 and a minus 3. And the minuses cancel. And in this case, you're left with y plus 6 over 2y. Now, those 6 or 8, I think we did 12 problems there. Those 12 problems is simplifying expressions. Okay? Now, after you simplify expressions, now we can move on to the operations. There's an operation right there. Number 1 rule. Factor everything. Okay, in this case, I'm going to factor everything. So I'm going to go down here and I'm going to do x plus 3 over x plus 5, x minus 5. That's shortcut number 3. Difference of 2 squares. If you've had Algebra 1 and Algebra 2, you know what I'm talking about. That's x plus 5, x minus 5. Now, I'm dividing by another fraction. X plus 3, x minus 3 over x plus 5. Now, when you divide by a fraction, you multiply by the what? Reciprocal. So I'm going to multiply by the flip-flop of this. So x plus 5 over x plus 3 times x minus 3. And see what happens. Take our red pen out. The x plus 5's cancel. The x plus 3's cancel. And you're left with, 1 on top and x minus 5 times x plus x minus 3. Now you could use the FOIL method and get a quadratic on the bottom, but they're not telling you to, they're just telling you to simplify. Now, the next question is one where we have to multiply through by the common denominator over 1 over the common denominator over 1. Now, if you've had Algebra 1 and Algebra 2 before, this is Algebra 2 problem, you should have seen this before. I'm going to erase what we just did, and we're going to have the whole page over to the side. So, let's go ahead and I'm going to, the common denominator of x and 2x plus 1 is 2x, or I'm sorry, is x times 2x plus 1. I'm going to put that over 1. X times 2x plus 1 over 1. Whenever you have two denominators that have nothing to do with each other, you just mash them together. Think of 3 and 7. What is the common denominator of 3 and 7? 21. You just mash them together. X and 2x plus 1 are like 3 and 7. They have nothing like each other. They're nothing like each other, so you just mash them together. Now that's going to give you the following. X times 2x plus 1 over 1. 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 I just rewrote that 4 times. Now I'm going to put my answer, my problem in. 1 over x minus 1, and I messed this up. Let me just write this in white over here. 1 over 2x plus 1. And we're multiplying there. Same thing over here. Because we're multiplying through by the common denominator. All this. And this is, oh, we only have one denominator. I'm sorry. So I don't need to. There we go. And that's going to be 4x over 2x plus 1. Okay, so I took x times 2x plus 1, put it over 1, and I multiplied through by all the terms. And watch what happens. Time for the red marker. That's going to cancel. That's going to cancel. And that's going to cancel. And all of that is going to be 2x plus 1 over 1. Over 1. You really don't need the 1. Minus x over 1 over 4x times x over 1. Now, since everything is over 1, you just combine everything. So this is going to be 2x plus 1 minus x over 4x times x. And that's going to be 2x minus x is x plus 1 over 4x squared. Now, take a minute and make sure you either write that down or pause the video and write that down, because that's how you solve, and this is what's called a complex rational expression. I'm going to give you a second or two to write that down. And now we're going to do number 3. All right, number 3. First of all, factor everything. And when you factor everything, you're going to get 2 over 2 times 2x plus 6 over 4 times 2x plus 6 plus 1 over x plus 3. So our common denominator, now you could factor out, okay, we should have okay, I'm sorry, I messed up. Let me, I didn't factor out all of what I should have. I can factor out a 4 there. So 2 over 4 times x plus 3, there we go, over 4 over 2 times x plus 3 plus 1 over x plus 3. Well, we got x plus 3 as a common denominator, but we got to multiply it by 4 because 2 will go into 4 and 4 will go into 4. So I'm going to take my blue marker and I'm going to multiply by 4 x plus 3 over 1 over 4 times x plus 3 over 1. Now what that's going to do, I'm going to write it, I'm going to put a baby step in here. 4 times x plus 3 over 1. And I'm going to put 4 times x plus 3 over 1. And I'm going to put 4 times x plus 3 over 1. And now I'm going to put my answer in because I multiplied through. So 2 over 4 times x plus 3. And remember, we're multiplying through. Over 4 times over 2 times x plus 3 plus 1 over x plus 3. Now take our red pen out. And that 4 cancels with that 4. That x plus 3 cancels with that. So you got a 2 up top. And let's see what cancels on the bottom. Let's see, that 2 cancels with that 4 makes a 2. That x plus 3 cancels with that. 2 times 4 is 8. And now let's see what cancels out here. X plus 3 cancels, and x plus 3 cancels. You're left with 4 plus 4. So it looks like to me 2 over 12, that's equal to equal to 2 over 12 is 1 over 6. If I did everything correctly, I'm looking to make sure I didn't leave anything out. That's a good problem because it makes you see where you can take something real complicated and you can break it down to something really simple. Okay? Now, what happens when you need to do an operation? When you do an operation, you're going to have something like this. Again, factor everything. This first one, I can factor out a 4 there, and I get 4, and that'd be x minus 8. Over the bottom, I can factor that x squared out, and that leaves x plus what? 1. The top up here, I can factor out an x squared, and that'll leave an x to the third minus x minus 2 over, we can factor out a 4 here, and that's going to be x squared minus x, 4x plus 4. And you could break that up. I'm looking to see that x squared, looks like x, no, this is x squared right here. There we go. This breaks down to, no, I was going to say that looks like x minus 2 quantity squared, but that's not going to cancel. It looks like to me the only thing that's going to cancel is the 4's and the x's. This cancels here, and this cancels here. I don't see anything else canceling. All right, let's do this one right here, number 3, and I'm skipping because you need to write down all these that you see, but I'm skipping to here because this is division. You don't divide by a fraction, you multiply by the what? By the reciprocal. So I'm going to rewrite this before I even start and put 27r squared m over 25 m squared n. And now we can cancel whatever we need to cancel. And if you want to write it out, you can write it out. 40 is equal to 2 times 2 times 2 times 5. 2 times 2 times 2 times 5. M n. Over 2, let's see, 9 times 2, that's 2 times 3 times 3. 2 times 3 times 3, r times r. Now I'm writing everything out because you can do it this way or you can cancel however you want to. 27 is 3 times 3 times 3. 3 times 3 times 3, r, and then an m. And then 25 is 5 times 5, m, n. So let's see what cancels. Well, let's see, the 2's cancel here. The r's cancel here. The m cancels here, and the m cancels here, and the n cancels here. The 5 cancels here. The 3 cancels there. The 3 cancels there. And it looks like to me, I got 4 times 3 over 5. That's what it looks like to me. 4, that's 4. 2 times 2 times 3 over, looks like the only thing I got down here is 5, which is equal to 12 over 5. So you can check me on that, but that's what I got. Down here, all factoring. Factoring, here you're going to multiply by, here you're going to change this, you're going to multiply by, 3c minus 9 over 2x plus 8. Here, you're going to multiply by 4x minus 4y over 21. Factor and cancel, factor and cancel. So those are some of the problems you're going to do with, this is operation, where you're doing multiplication and division. Factor everything, multiply by the reciprocal when needed, and cancel, cancel, cancel. I was hoping they had some adding and subtracting. Yep. This is where you get a common denominator. The common denominator here is a times a minus 1. So I'm going to multiply a times a minus 1 plus a times a minus 1. And I'm going to convert the numerator. How many times will a go into a times a minus 1? A minus 1 times, so 5 times a minus 1. How many times will a minus 1 go into this? A times 3 is 3a. Now you just simplify, and that's going to be 5a minus 5 plus 3a. 5a minus 5 plus 3a, all over, common denominator, a times a minus 1. And now, what's 5a plus 3a? That's 8a. So 8a minus 5 over a times a minus 1. And that should be your answer for number 7. All right, let's try one like number 9. Number 9, you got to factor because you got a quadratic. If you got a quadratic anywhere, you got to factor. So x over x That's going to be a 5 and a 6. Means 6 is going to be negative. This means unlike. And you're going to subtract 1 over x plus 5. So the common denominator is going to be x plus 5 times x minus 6. So I'm going to take my handy dandy and I'm going to write x plus 5 times x minus 6 minus x plus 5 times x minus 6. How many times will x plus 5 times x minus 6 go into x plus 5 times x minus 6? One time. 1 times x is x. X plus 5 will go into x plus 5, x minus 6 times 1 times x minus 6 times. So that's going to give you x minus x plus 6. Because you got to distribute this negative 1 right here. You got to distribute that. And you get x minus s goes out. You get 6 over x plus 5 times x minus 6. Now again, I am going over a review. So most of you that are watching this video, you should be saying to yourself, oh, I remember this stuff. I remember going over this stuff in Algebra 2. If you don't, then you might need to take 102 or 110 or whatever, because you might be having trouble. All right, we'll do one more. We'll do the bottom one right there, number 11. Number 11. Number 11 says p plus 1, 2. I'm going to change this to 3 over p plus 1, and then plus 4 over 2 times p minus 3, and then minus p squared minus 5 over, and we're going to do a p here, reverse FOIL, p, and then 1 and 3, and a negative 3, and a positive 1. So my common denominator is going to be 2p plus 1, p minus 3. So I'm going to go over here and write in white. Well, no, I don't have enough room. Let me copy that and go over to the whiteboard. Copy. I'm going to move over to the whiteboard. And there we go. Now, I'm going to get a common denominator, and that common denominator is going to be made up of everything on the bottom. It's not there. I mean, everything made up. So 2p plus 1, p minus 3. So I'm going to write it again. Plus 2p plus 1, p minus 3. Minus 2p plus 1, p minus 3. Now, how many times will p plus 1 go into this? P plus 1 times. That's going to leave 2 times p minus 3 times 3. 3 times 2 times p minus 3. How many times will 2p minus 3 go into this? P plus 1 times 4. And then p plus 1, p minus 3 will go in here that many times, leaving 2 times p squared minus 5. Now everything is over the common denominator of 2p plus 1, p minus 3. Now we're going to do all the top. Well, 3 times 2 is 6. So that's going to be 6p minus 18. Now you should be able to pause the video and you should be able to do this right here and get 6p minus 18. Now we're going to distribute the 4, and that's going to give us 4p plus 4. Now we got to be careful here. Okay? So that's going to be negative 2p squared, because that negative 2 is distributed, and that's going to be a positive 10. Now let's see if we can cancel something out up top. So 6p plus 4p is 10p. So that's going to be 10p. Negative 18 plus 4 is negative 14, plus 10 is positive 24. And negative 2p squared. All that over 2 times p plus 1 times p minus 3. Now I'm going to rewrite this because I'm going to see if there's anything that I can cancel out. So that's going to be negative 2p squared plus 10p plus 24 over 2 times p plus 1 times p minus 3. And I'm going to factor out a 2 here, negative 2, and that's going to give me p squared minus 5p plus 12. And over 2 times p plus 1 times p minus 3. And I'm going to see if this is factorable. Negative 2. I'm going to break it up into p here and p here. 3 times 4, no. 2 times 6, no. I don't think it's factorable. From what I can see, it's not factorable. The 2's cancel. So you can cancel the 2's. So I'm going to take my red pen and I'm going to cancel the 2's. And I don't know, I'm not checking it right now. Looks like, I don't think 1 and 12, 2 and 6. 2 and 6 will give you a 4 or an 8. So that won't work. 3 and 4 will give you a 7 and a 1. So I don't think that's reducible. I think you're done. So now let me go ahead and tell you this. If you're having trouble with this right here, then I would highly suggest that you take the 110 or the 102 or the algebra 2 or whatever you're trying to go. Because I'm going to be honest with you, you're going to have to know this algebra really well to do good in calculus, because your first calculus class is about 80% nothing but algebra. And it's this algebra right here. So with that, I'm going to go back to the worksheet so you can look at the ones that are left and see if you can work those. There's the ones that are on the sheet. And I think we did a couple of those. I can't remember how many we did. We did a couple of them. And hopefully you can work. And this is just the one I found I found it off the internet. So I just used it for problems. Sorry. And hopefully you can work on that section of complex rational expressions.